Here's a review of equations of circles in center radius form from geometry. This is called center radius form because it gives you the center and the radius from the equation. So notice here, both x is being squared and y is being squared. If we recall back to transformations of functions, the operation on the inside of the function tells you what direction to move. So this is a subtraction on the inside of the x. So this is moving a units in an x direction, and this is moving b units in a y direction, but it's the opposite sign. So therefore the center of this circle, which doesn't have any numbers, we'll plug in numbers later, is AB, the opposite sign of the numbers that are in the equation. X minus a, y minus b, both being squared, yields a center of AB. And the radius is simply the square root of the number on the other side of the equal sign. So although c squared is in the equation, the radius of this equation is c. So here's an example. We're going to find the center and the radius of this circle, and then we're going to graph that circle. So let's take a look at the numbers on the inside of the parentheses. There's a -2 in the parentheses. Inside of parentheses is with x, so the x coordinate of the center in this case is the opposite sign of -2, +2. Inside of the parentheses here in the y direction is +3. The opposite sign of +3 is -3. So therefore the center of the circle is 2, -3. And the radius will be the square root of the number. The square root of 9 is 3. So that's going to help us graph this circle. We're going to plot an ordered pair at 2, -3. 2, -3. There's the center of the circle. Now the radius is telling us to go 3 in all directions. So what I'm going to do is I'm going to go up 3, down 3, left 3, and right 3, and then make the best circle I can because I don't have a compass with me. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So here is the graph of x minus 2 squared plus y plus 3 squared equals 9. And there's our graph. So, given the equation, we should be able to graph pretty easily simply by identifying the center and then taking the square root of the number giving you the radius. Now what if they gave us the graph and we had to write the equation? Here are two examples. Let's write the equation of the following circles by identifying the center and the radius. Here's the first example. The center of this circle is 1, 2, -3, 1. Therefore, we're 2/3 of the way done with the equation. We know that the equation should be x plus 3 squared, the opposite sign of the x, plus y minus 1 squared equals a number. And that number is going to be the radius squared. So we have to find the radius. Here's the center, and we have to travel 2 units to the edge of the circle. So therefore, 2 squared. So our equation is x plus 3 squared plus y minus 1 squared equals 4, where the radius is 2. Okay, this example, we were able to move either horizontally or vertically to get to the edge of the circle. If you look closely, this ordered pair is on the circle, where this ordered pair is not. It goes slightly above the clean ordered pair. So we have to find the distance between the center, which is -1, -2, -2, and the origin. We know that this is a point on the circle, so we want the length of this line, or the distance of this line. If we take a look at this right here, we want to find the distance between -2, -2, and 0, 0. There's no reason to memorize the distance formula because the distance formula is simply constructing a right triangle and solving for the hypotenuse. So let me blow this figure up down here. We have this and this let's say that's the order pair negative 2, 2. This is the order pair 0, 0. And we want to find that distance. Now let's just pretend this is not on graph paper. So in order to get from negative 2, x, to 0, we have to move 2 units. In order to get from here to here, from negative 2 to 0, we also had to move 2 units. And all you'd have to do that is count the boxes. I had to move over 2 boxes to get even with that, and I had to move up 2 boxes to get to that. So we have a right triangle with sides 2 and 2. So we want to find the value of x, which is simply a missing value of a right triangle. And that's all the distance formula is. The distance formula is the Pythagorean theorem solved for the hypotenuse. So let's set up the Pythagorean theorem. 2 squared plus 2 squared equals x squared. 4 plus 4 equals x squared. 8 equals x squared. So therefore, the square root of 8 equals x. So now I don't want to express it as radical 8. I'm going to express this in simplest radical form by expressing radical 8 as radical 4 times 2. And that is a perfect square. So I'm going to say that this distance is 2 radical 2. So that's the radius. 2 radical 2. In the center, negative 2, negative 2. So we have all the information we need for the equation of this circle. The equation of this circle is x plus 2, opposite sign, plus y plus 2, opposite sign, equals the radius squared. 2 radical 2 is not the number in the equation. That's the radius. The radius squared is 8. And if you can't see that, we solved for x as the radius. The radius was radical 8. X squared is 8. If you want to just square the radius, that's fine. 2 radical 2 squared means both 2 and radical 2 are being squared. Well, 2 squared is 4, and radical 2 is 2. So 2 radical 2 squared is 8. And there's the equation of our circle.